So in this video I'm going to have a look at the Leaving Cert Higher Level Maths Paper 1 for 2017, and I'm going to have a look at question 7. So here we have two formula, and they're to do with populations of two cities. So sometimes it is possible to predict the future population in a city using a function. The population in Sapphire City over time can be predicted using the following function. So you have this function here, pt is equal to s times e to the power 0.1 times t by 10 to the power 6. So we don't know what s is here. The population of Avalon over time can be predicted using the following function. Q of t is equal to 3.9 e to the power of kt by 10 to the power of 6. So this time we're missing k here. In the functions above, t is time in years, so time is equal to 0 at the beginning of 2010. And both s and k are constants, so presumably at some stage we're going to have to work out what s and k are. The population of Sapphire City at the beginning of 2010 is 1,100,000 people. Find the value of s. Okay, so let's just write down, we're just talking about Sapphire City here, so let's write down the formula function rather. So it's p of t is equal to s, which we have to find, e to the power 0.1 times t by 10 to the power of 6. Now we're told that the population is 1,100,000, and that's equal to s e to the power 0.1 times, now t at this stage is 0. This is in 2010, so that's time is equal to 0. They tell you that here, and we've got to multiply that by 10 to the power of 6. So that will give us 1,100,000 is equal to s e to the power of 0. This just becomes 0 here. Anything to the power of 0 is 1, so it's just s by 10 to the power of 6. So that will just give us a value for s is this 1,100,000 divided by 10 to the power of 6, and that just gives you 1.1. So now we know that s is 1.1. Okay, so let me just move this up a little bit. So now we have our function for, we have our complete function for Sapphire City. Find the predicted population in Sapphire City at the beginning of 2015. Well, in 2015 you're talking about 5 years from 2010. So that means your time is going to be 5. So that's going to be s times, so that's 1.1. We've already worked out what s is. E to the power of 0.1 times t. Now remember, time here is just 5, so we're going to multiply that by 5, and that's by 10 to the power of 6. So if you multiply that out, you get 1.1 e to the power of 0.5 by 10 to the power of 6. So that will give us 1813593.398. Find a predicted population. So I'm saying the population here is, I'm just going to round it, so it's going to be 398 here, so it's just going to be 18135 Okay, so let's move on to the next question then. Find the predicted change in the population in Sapphire City during 2015. So you got to look at the population in Sapphire City at the beginning of 2015 and the beginning of 2016, or the end of 2015. So what we're going to do is look at P6 2016, this is beginning of 2016. So that's going to be equal to 1.1 e to the power of 0.1 times 6 by 10 to the power of 6. That will give us a population of 200,4331. So this is the population at the beginning of 2016, or in other words the end of 2015. So the beginning of 2015 was the answer to the previous question, this number here. So all we've got to do is find the predicted change in population. So in other words, the increase in population, or the change in population during 2015 is equal to 2004331 minus 1813593, and that gives us a change in population of 190738. So this is the predicted change in population during 2015. Okay, so let's move on again to the next question. I'll just move this up again. So the predicted population in Avalon at the beginning of 2011 is 3709795 people. Write down and solve the equation in K to show that K is equal to minus 0.05. So they're giving us the answer. We've got to work out where this answer has come from. So let's just write the formula down, or the function down first for Avalon. It's Q of T is equal to 3.9 e to the power of kt. Now by 10 to the power of 6. Now in this case here, we are told that the population at the beginning of 2011 is 3709795. Now remember, that's t is equal to 1. That's 1 year. So it's going to be 3.9 e to the power of k times 1, and that's by 10 to the power of 6. So all we've got to do is solve this. So let's see. The first thing I'm going to do is I'm going to divide across by 10 to the power of 6, and I'm going to divide across by 3.9. That will give me 0.9512294,872 is equal to e to the power of k. So I'm just left with this here, e to the power of k. K times 1 is just k. So what I'm going to do next is, because what we're looking for is a power here, I'm going to get the log of both sides. So again, I'll use natural logs here. 0.9512294,872 is equal to the log of e to the power of k. Now this here is just a number. You can type this into your calculator, you'll just get a number, and that number is in fact minus no, actually what we'll just do it in steps first. So let's just take, what you can do here with this part here is take the k and bring it down here. So in other words, I'll get k times log e to the base e, remember, and this part here, log e to the base e, is just 1. In other words, what would you raise e to the power of to give you e? Is just 1. So this here is just k, and as I said earlier, this here is just a number. So this number happens to be minus 0.049999 and so on. So in other words, what it says here, that k is corrected 2 decimal places. So in other words, k here is going to be minus 0.05 to 2 decimal places. So that's correct. Okay, so let's move on to the next question then. Again, I'll just move this up a little bit. It says, find the year during which the population in both cities will be equal. Okay, so in this particular case, what we're going to do is equate both functions. So we're going to take 1.1 e to the power of 0.1 t by 10 to the power of 6. Whoops, by, let me just do that again. So it's by 10 to the power of 6, and we're going to let that equal to the other function, which is 3.9 e to the power minus 0.05 t by 10 to the power of 6 as well. Well, the 10 to the power of 6's you can just divide across by that, and you end up with 1.1 e to the power of 0.1 t is equal to 3.9 e to the power minus 0.05 t. Now what I'm going to do here is just divide across by 1.1 first of all, and then I'm going to divide by this here. So I'm going to first of all divide across by 1.1, so that will give me 3.9 over 1.1. Then I'm going to divide across by this number here, so on this side I'll end up with e to the power of 0.1t over e to the power of minus 0.05t. Okay, so next thing I'm going to do here is we have e to the power of something divided by e to the power of something, so you can subtract the two powers here. So really it's going to be e to the power of 0.1t minus 0.05t, which you can just add these two, and that's equal to we'll say 39 over 11 here. Just going to get rid of these decimal points here, multiply top and the bottom by 10. Okay, so that finally gives us e to the power of 0.15t. I've just added these two now because we have a minus minus, and here we've got our 39 over 11. Okay, so again what I'm going to do here is just take the log of both sides, I think, because our power here is the variable that we're looking for. So it's e to the power of 0.15t, and that's just going to be the log of 39 over 11. So here again I can take this and bring it down, so I get 0.15t. And again here we've got a log e to the base e here, so that's just going to be 1. And here we have our log 39 over 11. Now on this side we just end up with 0.15t, and we have our log 39 over 11 here. So our t then finally is just going to be this here. We can just type that into a calculator, divide by 0.15, and you get 8.437, and so on. It goes on forever. Find the year during which. So it's going to be the question was, find a year during which the population in both cities will be equal. So it's almost 8.5 years here, so it's going to be during year 8. Okay, so that's part E. So let's have a look at part F then. Find the predicted average population in Avalon from the beginning of 2010 to the beginning of 2025. Okay, so here we're talking about our function is q, not g, it's q of t, and it is equal to 3.9 e to the power of kt by 10 to the power of 6. What we're talking about here is an average value integral. So we're looking at 1 over, we're talking about 15 years here, so it's going to be 15 minus 0, and then we're going to integrate from 0 to 15, and it's the function 3.9 e to the power of kt. Now our k here, by the way, is just minus 0.05, I should have put that in here, times t by 10 to the power of 6. And what we've got to do is work out what this t is here. We've got to work out what the predicted average population from the beginning of 2010 to 2025. So we know what t, we'll integrate this and we'll substitute in for t, and we'll find the average population from the beginning of 2010 to 2015. So let's do this. So we've got 1 over 15 here anyway. I'm also going to bring outside, what I'll actually do here, I'll just go back a little bit here. We have a constant here, all of this is multiplied, so we have a constant here and a constant here. They're all multiplied, so I'm going to bring them outside the integral symbol here if you like. So it's going to be 3.9 by 10 to the power of 6 over 15. So now all I've really got to do to integrate from 0 to 15, e to the power minus 0.05t, and this is with respect to t, of course. So let's work this out. Now I think I'm going to run out of a little bit of room here, but anyway, let's see, we can sort that out in a minute. So we end up with 3.9 by 10 to the power of 6 over 15. Now we've got to integrate e to the power of minus 0.05t. Now really you could just start like this. It's going to be e to the power of minus 0.05t anyway, because if you integrate e to the power of x, you get e to the power of x. So if you integrate e to the power of minus 0.05t, you'll get e to the power of minus 0.05t. However, if you think about it, if you differentiate this, you'll get e to the power of minus 0.05t, which we have up here. But you also will have to differentiate this bit here, so we'll be left with minus 0.05 multiplied here. So we've got to get rid of that minus 0.05. So really what we're going to do is end up with 1 over 0.05 here, minus 1 over 0.05 here. So this is what our integral is, and we've got to do, our limits are 0 to 15. Okay, so what we end up with then is 3.9 by 10 to the power of 6 over 15. Now we've got to multiply that by, we've got to substitute in 15 here, so it's going to be minus 1 over 0.05 e to the power of minus 0.05 times 15, and then we've got to put in minus 1 over 0.05, that's this bit here, e to the power of minus 0.05, and then we've got to put a 0 in here. So this is our integral here with the substitutions now. Okay, so what I'm going to do here is I'm just going to move up here a little bit because I'm just running out of a little bit of room, so I'll just put a line down the middle here, and we'll continue on here. So let's see, we have 3.9 by 10 to the power of 6 over 15, and we have all of this here. Now this will become plus here. If you can work this out on your calculators here, and you will get minus 9, so I'll just do it here, minus 9.4 4733 1055, and then we're adding this here, just becomes 20. If you type this into your calculator, you will just get 20. Okay, so when you work all of this out, then you'll just get a number. You can do all this, is just calculator work at this stage. So what you end up with here is 27436 So this would be the average. Just get rid of this here, put it right, draw it properly. So this is the predicted average population in Avalon from the beginning of 2010 to the beginning of 2025. So this here is our final answer. Okay, that's to the nearest person now, so you do get a decimal there, but I just rounded to the nearest person. Okay, last bit then is question, or part G here, and it says use the function qt is equal to 3.9 e to the power minus 0.05t by 10 to the power 6 to find the predicted rate of change of the population in Avalon at the beginning of 2018. The predicted rate of change. So let's have a look. We have our function again, g of t is equal to 3.9 e to the power minus 0.05 t by 10 to the power of 6. So we were looking for rate of change here, so we want to differentiate this function here. Now this is going to be, let's see, we want to differentiate all of this here, so it's going to be this here and this here we can put together if you like. So we really end up with 3.9 by 10 to the power of 6 e to the power of minus 0.05 t. So that's like, it's like if you have, say, 3 e to the power of x. If you differentiate that, it would be 3 e to the power of x. So that's all I've done so far. However, this is not an x here, it's a minus 0.05x if you like. So I'm going to have to differentiate this bit up here as well. So let's just differentiate this part here. If you differentiate this part here, you get times minus 0.05. Okay, so that's what we get when we differentiate all of this. Let me just put that a little bit neater. Let's put the 10 to the power minus 6 out where it was previously, out here. I'm going to multiply minus 0.05 by 3.9 and I get minus 39 over 200. I get e to the power of minus 0.05t, and then I've got my 10 to the power, put that out here, by 10 to the power of 6. So that's the rate of change of the population in Avalon at any time t, but we want at the beginning of 2018. So from 2010 to 2018, that's 8 years, so it's going to be, what we really need is g dash 8, so t is equal to 8 in other words. So in other words, it's minus 39 over 200, e to the power of minus 0.05t by 10 to the power of 6. So look, when you work that out, you get minus 130712.409. So this is the rate of change, the predicted rate of change of the population in Avalon at the beginning of 2018. And you can see that what's actually happening here is the population is decreasing by this amount per year at the beginning of 2018. So the population in Avalon is actually decreasing. Okay, so that's it for question 7.